Okay, in this video we're going to look at a little bit more complicated logs that we're trying to solve. So as an example, let's say we have the log of x plus the log of 8 is equal to 2. Well, we know what our base is, even though it's not written. It's a 10, so let's go ahead and just write that in. And now before we can do anything, we have to combine these logs or condense them. Because the operation between the two logs is addition, we're going to be using our product property, which says that we can combine these two logs into a single log with the same base by multiplying our values. So we get log base 10 of 8x, because x times 8 is 8x, is equal to 2. Now to solve this equation, we need to rewrite it as an exponential because our unknown is in our value spot. So to rewrite this as an exponential, we're going to get 10 to the second power is equal to 8x. 10 squared is 100. And now we need to divide both sides by 8 to find out what x is. 100 divided by 8 is 12.5. So x is 12.5. Okay, let's try another one. And this time, let's have our unknown be in our exponent. We'll have an exponential equation to solve. So let's do 12 the x minus 6 minus 5 is equal to 48. So our first step we need to do is get our exponential term by itself on one side of the equation. So I need to add 5 to move that to the other side. So I'm left with 12 to the x minus 6, and I'm going to put parentheses so it's clear that's the exponent, is equal to 53. Okay, so now we have our unknown in the exponent, and that term is by itself. Our next step is to rewrite this as a log equation. So this is going to be log of, our log base 12 of 53 is equal to x minus 6. To be able to enter this value in the calculator, I need to rewrite it as using the change of base formula. So that's going to become log of 53 divided by log of 12. So again, it's the log of our value divided by the log of the base. And that's going to be equal to x minus 6. Now when I plug this into the calculator, log of 53, close parentheses, divided by log of 12, close parentheses, I get 1.59776. That's going to force me to round it up. So this will become 1.5978 is equal to x minus 6. Final step here is I need to know what x is. So I need to move this 6, and I move it by adding. So plus 6, I get x is equal to 7.5978. And again, on this one, we had to take our equation, add the 5, convert it to a log, do change of base, plug it in the calculator, and then add that 6 over. Okay, let's try one more equation. And let's have this one where we use our equals. If we have a log, let's say log base 6 of 2x plus 7 is equal to log base 6 of 15. If we have two logs with the same base equal to each other, we can say the two values are equal to each other. So I'm going to set my two values equal to each other. So 2x plus 7 is equal to 15. And now solve for x. Subtract 7 from both sides. We get 2x is equal to 8. And now I divide by 2. We get x is equal to 4. So anytime you have two logs equal to each other with the same base, I can say the values are equal to each other. It's a one-to-one property. So I rewrite the equation with just the values equal to each other and do some algebra to solve it. Okay, this should help you solve any type of solving that you need to do.